In today's video, I am going to prove the triangle proportionality theorem by using vectors, and you will find that using vectors could be very elegant and sophisticated. We'll not use any extra drawing or extra construction. Now, what is this theorem, triangle proportionality theorem? It says that if a line is parallel to any side of a triangle, so ABC is a triangle, BC is parallel to L, and if this parallel line intersects the other two sides, which it has intersected at D and E respectively, then it will divide the line into the same ratio. So we will use vectors to prove this, that is AD by AB is equal to AE by AC. This we are going to prove using vectors. Now, as you know, vector has got two things. One, it has got a magnitude, and the second, it has got a direction. So we will denote direction by this sign and modulus by this sign. So throughout the proof we will use this. So this means, for example, when you say AD, we are talking about this vector which is going from A to B. And when you say AB, basically we are talking about the length of AB, right? So we will use that throughout the proof. Now what has been given? Given is that L is parallel to BC. So we can say this vector DE is parallel to vector BC, right? Or DE is equal to lambda 1 BC. Since these vectors are parallel, one vector can be represented by another vector multiplied by a scalar quantity. So this is a scalar quantity. So we can say lambda 1 is equal to mod of DE by mod of BC. So lambda 1 is mod of DE by mod of BC. Similarly, let's say AD is equal to, that is, we are talking about vector AD is equal to lambda 2 into vector AB. Why we could write this? Because AD and AB are parallel. So I can represent AD as a scalar multiplication of AB. So it is lambda to AB. So L lambda 2 becomes mod of AD by mod of AB. Similarly, we can put lambda 3 is equal to mod of EA by mod of CA. Now, if we can prove lambda 1 is equal to lambda 2 is equal to lambda 3, then our job is complete. So let us do that. So you can see this, I am just writing again. Vector D is lambda 1 into vector BC. Vector AD is equal to lambda 2 into vector AB, and EA is equal to lambda 3 into vector CA. Now if you can notice, vector AB plus BC plus CA is a zero vector. Why? Because we are starting from A, we have come to B, and then C to A. So we are going back to the original position. So vector AB plus vector BC plus vector CA is equal to a zero vector. Similarly, AD plus DE plus EA. This is also a zero vector. Now, if you see this AD, if we substitute the values of AD, DE and EA, we will get lambda 2 AB plus DE means lambda 1 BC plus EA means lambda 3 CA. This is a zero vector. And if I multiply this vector by lambda 2, what I'll get? I'll get lambda 2 AB plus lambda 2 BC plus lambda 2 CA is equal to a zero vector. Remember that when I multiply a scalar into a zero vector, the resultant will also be a zero vector. Now this is, let's say, equation 1 and this is equation 2. I subtract 2 from 1. So lambda 2 AB, this will result with a zero vector. Basically it will get cancelled. And this will become lambda 1 minus lambda 2 into BC plus lambda 3 minus lambda 2 into CA. 0. Now, interesting thing is that addition of two vectors will result into a zero vector when? What are the possibilities? Case 1 is these two vectors are equal in magnitude and opposite in direction, exact opposite in direction. But since it is a triangle, this vector BC and CA cannot be opposite directions, right? So this case 1 is not there. Case 2, this is only possible when this vector is 0 and this vector is 0. So each vector individually is 0 vector. Then only the addition of these two vectors will be 0, provided this case 1 is not there. That means two vectors are not opposite. So that means we can think this as a vector, total vector. This is 0 and this is 0. These both vectors are 0. Now this is 0 means this vector is 0. BC is not 0. Because BC is a part of a triangle. The length of BC cannot be 0. So BC cannot be 0. So that means lambda 1 minus lambda 2 is equal to 0. Similarly, here lambda 3 minus lambda 2 is equal to 0. Here, from here we get lambda 1 is equal to lambda 2 and lambda 2 is equal to lambda 3. So basically what we have got is lambda 1 is equal to lambda 2 is equal to lambda 3. So what is lambda 1? As we said, lambda 1 is mod of DE by BC. What is lambda 2? AD, mod of AD by mod of AB. And lambda 3 is equal to mod of EA by mod of CA. So lambda 1 is equal to lambda 2 is equal to lambda 3. It means DE by BC is equal to AD by AB is equal to AE by AC. So the theorem is proved.